In example 13, we are told that a discrete random variable x has a probability distribution as shown in the table below. Now, we have a distribution, probability distribution as shown below. Now, when x is 1, the probability is 12 out of 25. When x is 2, the probability is 6 out of 25. When x is 3, the probability is 4 out of 25. When x is 4, the probability is 3 out of 25. Question. Write down the probability distribution for y, where y is equals to, let me just write it, where y is equals to 2x plus 1. There are two approaches to actually solve this question. One, we are told to give the probability of y, where y is 2x plus, we may have y, another row or column of y, and for every value of y, we have to multiply x by 2 and then add 1, because that is the requirement. So when x is 1, 2 times 1, 2, and 2 plus 1, y is a 3. 2 times 2, 4, plus 1, 5. 3 times 2, 6, 7. And then we have a y, which is going to be a 9. Incidentally, only the value of x has changed to y, and the concentration of x, as much as it's becoming y, has not changed. So the probability of y is equals to y remains the same as it was when x was x before it was transformed into y. So the probability of y, 12 out of 25, 6 out of 25, 4 out of 25, and 3 out of 25. Remember, changing x into y does not change any concentration. It doesn't mean that the concentration of x or of y has changed. So the probability just remains the same, because all the values of x change in the same way to become the values of y. So the probability basically remains the same. But part B, find EY. Find expected value of y. And we know that the expected value of y is supposed to be sigma y times the probability of y. And we have to now create another column of, even if we don't create another column, we may talk about, this is the value of y times its probability. So 3 times 12 is giving us 36 out of 25. Then 5 times 6, 30 out of 25, because we have to have a column of y times the probability of y. So when y is 7, times the probability of 7, which is 7 times 4, which is 28 out of 25, plus, of course, 7 times 3, 27 out of 25. If you add all these, then you realize this is 121 out of 25. And if you divide that one, 121 by 25 is basically 4.84. But if you look at what is expressed or explained in statement number 1 on top of our board, whereby we would have been able to say when y is equals to, and this is now or, this was either, it should have been e of 2x plus 1, which is basically what we can see here. Our A is 2, so A multiplied by EX plus our B, which is 1. Let's see if this gives us 4.84. What about EX? E times X. The EX is X times the probability of X. So 1 times 12. 1 times 12 is 12. So EX is equals to, or 2EX for that matter, is 2 multiplied by, we have 12 out of 25 plus 12 out of 25 plus 12 out of 25, and finally 4 times 3, again 12 out of 25. All these we have to add 1. Let's see, this is 2, 12 times 4, 48 out of 25, which is 96 out of 25, plus 1, which is 96 times, or rather, 96 divided by 25 is 96 divided by 25 is basically 3.84. When you add 1 to this plus 1, you will surely get 4.84. And we have seen that is what we had realized here. So both ways will take you home. So if you wanted to actually get the value of y, you could get the value of y after substituting x in this particular linear equation, and you get y and calculate ex. If you did not want to follow that route, you would easily not bother with what the value of y is, and of course use the formula, and you will still get home. All right?